Good morning. This time I'm doing a video about some references from the ISO standards, how to choose the probes according to angles, frequency. I'll make a long one and then I'll do the short one and put it like here in the beginning, so there is short information about how to do that, and then the long one will be after that. So okay, now here is a summary. The summary about the size, about the frequency of the probe, cleaning area, and using two angles. So the summary is like this. We start working with a thickness of 8 millimeters. We have three angles, and according to the thickness, we use a small probe to the thickness of 30 millimeters if the angle is 70. Now, then you should use the bigger probe. Now, if the angle is 60, you can use a small probe until something here. That's small and that's already big, but it's approximate. So from the thickness of like 30 something, we should use the bigger probe, and with the angle of 45 we need to recalculate, because it should be bigger, should be somewhere here. The calculation here is wrong because it's only the cleaning area, not the path calculated. Now that's big and small. So big is like this and small is like this. Now the other thing is megahertz. According to the ISO 17640, the range we're using is from 2 to 5, and the higher frequency is used to improve range resolution if you are using this standard to identify the defect, exactly what it is there. So if not, then we can use lower frequencies like 2 megahertz, 2.5 megahertz for standard use. So we start with this. Now, coupling for sensitivity settings should be used the same material as for testing. So if you use oil, you should use, it's recommended to use oil for everything. If you use ultrasound gel, then you should use ultrasound gel for calibration and sensitivity settings, and then also testing. That's the recommendation. And if you are using the ultrasound for pipe testing, so the thickness is also 8. The minimum thickness is 8 millimeters, and you can start working, checking the pipe with a standard small probe if the diameter of the pipe is from, let's say, 110, 111, 112. Okay, that's where we start, and we don't need to modify the probe in any way. If the diameter is smaller, you need to make it fit more closely, so the gap is smaller or there is no gap in between the probe and the pipe you are testing. That's the summary. Now the long part is going after this. How to choose the probe according to the angle and frequency. So I have here a table that I use as a reference. So I have here the thickness of the metal, and then the probe size and the angle of the probe, and calculated the length of the cleaning surface. When you work, here is the cleaning, here is the surface of the weld. So when you work with a probe, how much to clean according to the thickness of the metal, because you need to clean 2 legs, 2 and 1.25 according to the standards. So what I have here calculated is how much you need to clean the surface area, so according to the thickness. And then we work with ultrasound standard from thickness 8 according to ISO 11666, and then to big thicknesses. Then how to choose according to the frequency, how to choose according to the thickness, and how to choose according to the weld geometry, what kind of the weld, and how you choose the angle according to the weld, because if your weld is X, then what angle to use to check, and if your weld is like this, what angle to choose to check the weld. So also a thing to think about, but maybe not for this video. So now let's talk about the frequency. The frequency, it's written in 17640. I have it here. It says, according to the standard, we work with a range of 2 to 5. So our probes, if we work with a standard job, should be from 2 to 5. Another thing that is written there is the higher the frequency we can use to improve range resolution. And if we need to identify the defect, what is it? A pore, a crack, whatever. And this is all written in 23279. We won't do that, but it's recommended in 731 to use higher frequencies to improve resolution. So if we don't do that, then it's recommended to use lower frequencies, and that is then 2 megahertz, 2.5 megahertz. That's the thing that I usually use to work in ultrasound. Okay, now what else do we have? Okay, coupling, it's in the standard 735. For sensitivity settings and for testing, use the same. So it's better to use the same, not oil on the calibration blocks and then ultrasound gel during the work. It's better to use the same everywhere. So that's the recommendation. Okay, what else? What we have here, so the frequency is recommended, let's say this one, the standard one, what we start with. Okay, now the size, transducer size, because I don't have it here later. You can have a bigger probe or a smaller probe. The size also matters, and here what I have here, recommendation is in 733 in ISO standard. And what it says is small probes from 6 millimeters to 12 millimeters, transducer size or diameter should be most useful when working short sound paths. So when the distance is short. Now, if the distance is angle beams plus 200 millimeters, that's 20 centimeters, transducer size should recommended more suitable 12 to 24 millimeters. So here I have in Lithuanian small and big. So here the cleaning area here, if the thickness is like 26 of the metal and you are using 70 degree probe, you can still be using, let's say, a small probe. Now this is okay, the small probe here, when the thickness is 30 and you want to use 70 degree probe, it's recommended here to change to the big one. Well, it's recommended, but from here didelis это big, let's say, and mažas is small. So here are the thicknesses of the small probes for the 70, and here the thicknesses of the big probe. I'll pause it and show you what's the difference between big and small. The difference between big and small here, you can see that here is a small one that's 8 times 9 millimeters. You cannot see it here. 8 times 9 millimeters, and here is 14 times 14. Okay, so the difference is like that. So for this part the small is used, for this part the bigger is used. Recommended, okay, that's according to the standard. Let's put it aside. Now if you use the 60 degree angle, then here is still small and here is big one, because the length of the cleaning area here is 20. So the length of the cleaning area is 20. Okay, it's 200. So, well, it's approximate because the sound path is not 200. It's longer because the sound goes this way, but still some kind of reference. And then if you use the angle 45, then what you have is small everywhere. So you can use a small probe because the length of the sound path for 50 is still small because it goes like this, something like that. So this length is small because it's 45 and 45, so it's not long enough. Okay, but it's thick, so maybe no, that's not right, because here is small, but this thing is 50 and 50, so it's 50 here, 50 here, it's 100. Yeah, I'll need to check that because the thickness is big and this one is small, so that's only for the reference, but the logic is like this. So big, small. Here is small, here is big. 200 small, big, and small, but you see that you have to check it if you want to do it exactly according to the recommendation. Okay, so the big or small probe, the frequency here is 2 to 5, the higher, okay, and coupling. What else I have? I have the pipe. I have the pipe. One moment. For the pipe, the calculation is in ISO 17640 734, and there are formulas, what's the gap size and things, and the formulas say what? That you can work with this small probe if the diameter is 112. 111, okay, it's 51. You start working with 0.5. Okay, so here is the starting point, the diameter of the pipe that you can work with a normal probe without doing anything with it. Okay, you don't have to make it fit like this. Okay, you don't need to, it's good enough. Okay, if you need to work with a smaller size, then you have to make it round. Okay, so that's the reference line we are working. We can work with a pipe, and still the thickness of that should be 8, the starting point. What I have also is this thing, the geometry of the weld. So the logic is like this, and you have to check all the weld up down. So you use one leg, two legs, and the angle is important because you need to check the better angle to have, how to say it, it's better to have a 90-degree angle to the defect. Okay, and the defects are most often here and here. Here can be a crack. Okay, so you should not check like that in this direction, because it will, the sound path will go this way and then this way, reflect and go somewhere. So when you move your probe to here, then you need to find a place to go like this and to find a 90-degree angle to here, so it reflects back to your probe. Okay, the logic is this. So another thing what I have is the logic of what angles to use, because I had one of the problems to solve. I didn't have, here is the thickness 10, okay, and here is the weld, and I have 45, 60 and 70, and the starting point of the sound is different. So when you start in here, you cannot check this with a 45 degree, it's too small thickness. Okay, so it's, you have to check this weld with a third or fourth leg. Then if it's 60, you need to use like the third leg, because the sound goes from here. And if it's 70, you still cannot use the first leg, because the sound, it goes from, it's X value, and if it goes from 18 or like 13 from the probe, So you will check this part, you cannot check this. So, and if you don't have, you have limited space here, you have a problem with a small thickness. So the angle 45, that's bad. That's why with a small thickness you use 70 or 60. You can see that in this when the thickness is 15. So here is also, but it's better. Maybe with a second leg and then with a third leg. Now with the 60, you already can use the second leg normally, and with the 70, part of the first leg, and with the second leg to check this kind of weld. So for smaller thicknesses, we start with 70. And then 60. The logic is this, because according to the standard you sometimes need to use two angles. So if you need to use two angles for let's say thickness 10, you use 70 and plus 60. Now in the middle is like 30, so you use 60 and then whatever you want, either 70 or 45. And with a bigger thickness, you start, let's say, with a 45-degree angle like here, and plus the second one would be 60 degrees, because it's easier to work, not, well, smaller cleaning surface. You check here 30 centimeters, here 20, and here like 13, 20 and 30. So you can clean not 30 for 70 but 20 centimeters, and 20 centimeters cleaning area is like this paper. So you need to clean this part from both sides of the weld, so a lot of work to do. So when you use two angles, here is the reference. It's gray, but it should be green. Okay, so a lot of information for me to use when choosing the angles and stuff in this table. And I think that's it. So that's the long part. Now I'll do the short part somehow and put it in the beginning as a reference.